Hello there. This is Mark Summers. I'm an adjunct professor out at the Austin Community College. I teach in both the A&E CAD department and the engineering department. Teach a couple of different classes. Currently, they're co-listed, so students from the A&E CAD department and from the engineering department both are in the same class, which is good. We get to commingle with each other and learn from each other. So there's the two class numbers, DFTG 1429, ENGR 1304. The name of the course is Electromechanical Design, which is actually a great name for the course because that's what we do. We've already learned how to do CAD stuff. We learned SolidWorks, and we learned how to use SolidWorks as a design tool to do electromechanical designs. And so the CAD side is, like I said, using SolidWorks to do mechanical designs. And on the engineering side, we use the same tool, the same models to do finite element analysis, do stress analysis, deflections, and things like that. And then we also do a little flow simulation, all within SolidWorks system. So switch over to some quick lecture slides here, talking about my experience. And so I've been a mechanical design engineer / analyst for 30 years. Used most every CAD tool since 1984 that's been out there. So I've got a broad range of experience with that. I've been teaching for a little 15 years at Austin Community College, Texas State University. And you can see my background. I got a couple of master's degrees I've got recently. One in technology here at Texas State with a minor in mathematics. And I just recently finished my Master of Science in Engineering in manufacturing, specializing in manufacturing engineering. So this is a kind of expertise from my work experience and my education experience that I bring to class each and every day for students to start their own careers. And here's a quick list of some of the classes I've taught at ACC. I've taught most of the CAD classes out there. Here's some courses I've taught in the engineering technology department here at Texas State that are closely related to classes that are available in the BAT program out at ACC. And here's some manufacturing engineering courses I've taught at Texas State. Some of my work experience includes working in the aerospace industry, doing wind tunnel model design and radar cross-section model design and testing. And I got to travel all over the country doing testing when I worked at General Dynamics. Next position I had was Lockheed here in Austin, where we did design of ground support equipment for folks like NASA. And I started doing learning about finite element analysis at that point. We worked on an Iridium satellite system here in Austin, superconducting super collider that's since been canceled. It was to be scheduled to be built in Waxahachie, but worked on that while it was going. And worked on a mobile shelter, the bottom right picture down there, that we took to Aberdeen Proving Grounds. And that was another good experience where we did some aircraft loading testing and evaluation of the system. Next moved on to the semiconductor equipment industry. Worked for a company called Eaton that got bought out by, changed names, to Axcelis. And then we did wafer handling. We had a 200 millimeter ion implanter that we built here in Austin. We had a joint venture with a Japanese company to transition from 200 millimeter technology to 300 millimeter technology. And so that was a great job for a mechanical design engineer like myself. We had lots of robots, lots of moving parts, and we had a ton of working alongside electrical engineers and software engineers to make all the magic happen. And so after I got through with that, I started working at an automated test equipment company here in Austin called Symtex that got bought out by AAI and eventually bought out by Textron. But we did mostly test fixture, electromechanical test fixtures. There's a picture at the bottom left, the first design I did while I worked there for Motorola to test their vacuum sensors, and did a lot of electromechanical packaging tasks, and got to work on the AAI drone system, the top right picture there, where we designed and fabricated a center of gravity and weight system for the existing Shadow 200 drone. And in the bottom right picture is a 787 Dreamliner that we had a project with to do some leak testing for their passenger and cargo doors. So quite a range of experiences, but it all ties back to mechanical design, electromechanical packaging, and that's what I get to teach to ACC students that take my classes. And so the last slide here is a link to the YouTube channel that I have a lot of videos. And so if you're interested in this kind of stuff, you can pop onto the YouTube channel, subscribe to it because I post new videos pretty regularly, and you can get more information there. So let's go. I'll take a quick look at the YouTube channel. Drag that window over here if I can. So it's hopefully not too difficult to navigate. I got lots of different content, and so if you go to a playlist, you come down here and you got the different courses that I teach at both places, and you just find our class, which is where is it? Yeah, right here, 1304, and other courses. So you find the course you're in and click on the link, and you can see all the projects in the that we have in the videos, or excuse me, all the projects we have. I have videos for all that stuff. All right, so let's move on to some kind of some hands-on, get an idea what kind of projects we work on. So all the projects we have are real projects that I've designed and worked on in the past. So here's a waveguide, and we learn about different waveguide basics. We don't go into a lot of theory, but we talk a little bit about engineering concepts and electromagnetic waves, different frequencies. So you design a custom waveguide based on requirements from the customer, and we learn how to build part models, assembly models, and then we get to do configurations, so you can build different sizes of these waveguides depending on the requirements from the customer, and they're easy to switch between. So you learn a little bit about doing waveguide design and also about different configurations. Let's see what's next on the hit parade here. And these projects change from semester to semester, and I add new projects all the time. So here's a little weldment that was part of that UAV weight and center of gravity fixture that I designed, and you can see here's the actual part, and it's this is scrapped out because it was God, what was wrong with it? But anyway, it's different aluminum pieces, and you can see if I can get the camera working over here, it's welded together. So they're pieces of aluminum tubes, and they get welded together. So we learn a little bit about welding processes and heating and warping, and it's got some other components that get mounted on here. So we learn how to do that in SolidWorks, and again, learn the design part of it as well. And going through my list of stuff here, what's next on the list here? We've got, see what's going on next here. Oh, there's our final project. This is electromechanical. This is a typical electromechanical design. It's a RF chassis with lots of RF components in here. And I don't give you the drawings of the models to build. You design it yourself. And so I give you the requirements based on interconnect diagrams and parts lists, and you design your own product. And you can optimize the shape such that we minimize the size of the chassis to cram as much components in here. That'll save the customer money because they can not have to worry about having a big RF chassis or RF rack to put these in. If we can squeeze it into a smaller space, then we can save the customer money in having to buy a bunch of chassis. And these are all mechanically constrained, so we can test to make sure the thing fits correctly. And we do cable routing. Here's one of the cables we use. And these are real SMA high frequency 40 gigahertz cables, and we route these, not me, you route them in the chassis based on the customer requirements that you get. And so that's one of the many projects we work on during the semester. And it's like I got one more picture here. Let's see what it is. In addition to doing the mechanical design, we also do drawings. We'll learn about geometric dimensioning and tolerancing, how to do drawing views, how to specify the manufacturing processes and the dimensions and the tolerances, all using standards, in our case ASME Y14.5, and learn about that. You've learned it in your earlier classes, but we continue to expand on some of those things. So you're doing models, you're doing assembly models, you're doing real designs, and you're doing documentation, part drawings, assembly drawings, to document these designs. And so hopefully kind of went through a lot of that quickly, but just wanted to give a feel for students that are trying to figure out what it is that is available for me in the mechanical CAD program. And this is what I teach in the electromechanical design course, and it's a lot of fun for me, and I find the students that take the course also enjoy it. So thanks for watching. If you have any questions, you can, where's my little slideshow here? You can contact me at those contact information in the screen there. So thanks for watching. Enjoy your day, and I hope to see you in the next semester coming up.